Imagine trying to construct a massive 100-story skyscraper without a master blueprint, right? Like, you wouldn't just start pouring concrete and hoping for the best, would you? No way. It would be total chaos. Well, building modern, high-performance web applications requires that exact same level of architectural precision. So, welcome to this explainer. Today, we're diving into the architect's blueprint for building scalable web apps. We're going to explore exactly how you take a really complex operational need and transform it into a highly available, blazingly fast digital product.
Okay, let's dive into this. To construct our digital skyscraper, we're going to follow a precise four-stage agenda. First up, the modern web ecosystem. Second, choosing a front-end foundation. Third, the three pillars of performance. And finally, aligning tech with business.
Section 1. The modern web ecosystem, reimagining the browser.
Before we lay a single digital brick, we have to recognize that the entire internet landscape has fundamentally shifted. I mean, the browser is no longer a tool just for viewing static documents. It serves as an advanced runtime environment. We literally have to stop thinking of web browsers as, digital filing cabinets for text and hyperlinks. Today, those web tabs run complex desktop-grade software applications. We are talking about heavy enterprise portals, real-time interactive collaboration dashboards, the whole shebang of massive global SaaS platforms. The browser is the core interface connecting your organization with the entire world, and because of that, it absolutely has to handle sudden traffic spikes while remaining exceptionally fast and, of course, completely safe.
Section 2. Choosing a front-end foundation. Laying the groundwork. Now that we understand the environment, we've got to pour the concrete. In web architecture, a foundational milestone is choosing your rendering and component structure. And honestly, this single blueprint decision dictates absolutely everything downstream. We're talking initial load times, development cycles, and your long-term organic search layout. Now, what's really interesting about this slide is the contrast here. On one hand, you have single-page applications, or SPAs. These are incredible because they load the entire bundle just once, swapping content dynamically for this really fluid app-like experience. But contrast that with server-side rendering, or SSR. If your business requires blistering fast initial page loads and top-tier search engine discovery, SSR is an absolute powerhouse. You are essentially pre-building the page on the server so the user's browser doesn't have to do all that heavy lifting.
And that perfectly tees up this concept of progressive hydration. This is basically the process of rendering your views on server endpoints before shipping them to the user. Now, this isn't just some fancy engineering flex, okay? It is an absolute business requirement for large software products to ensure search optimization while maintaining those interactive speeds. It guarantees the user gets a fast, visible page instantly while all those complex interactive elements just load seamlessly in the background. It's a real game changer for future-proofing your apps.
Section 3. Three pillars of performance, erecting the structural supports.
With our foundation firmly set, it's time to shift our focus to the heavy-lifting engineering concepts. As a web application scales up, technical debt can mount rapidly, like really rapidly. So to keep your web application from crashing under aggressive sudden traffic spikes, we rely on three distinct load-bearing columns. Those are deterministic state management, decoupled microservice APIs, and comprehensive cloud security. Let's look at how this builds a truly robust framework, starting with that very first pillar. First up, deterministic state management. As your web app integrates multiple live features, so think notifications popping up, chat windows, live data feeds, tracking global variables gets incredibly messy and highly error-prone. Actually, scratch that, it becomes a total nightmare. You absolutely must adopt structured data workflows. This ensures that whenever the underlying database changes, your visual views alter cleanly and predictably. Following this principle is exactly what keeps your browser tab lightweight, fast, and highly responsive, rather than getting all bogged down by conflicting data. The second pillar is decoupled APIs. Modern web software demands that we separate the front-end display, which is what the user actually sees, from the back-end calculations, where all the heavy data crunching happens. By channeling your communications through structured RESTful interfaces, or maybe fast GraphQL channels, your engineering team can actually modify individual database logic behind the scenes without ever disrupting the active customer interface. It's kind of like remodeling the kitchen of a busy restaurant without interrupting the diners out in the main seating area.
And our third structural support is comprehensive cloud security. Remember, web-accessible code faces constant, automated threat scanning from the outside world all day, every day. Protecting your application requires layering robust defenses directly into your continuous deployment systems. We're talking about strict cross-origin resource sharing rules to control data requests, multi-factor verification tokens to block unauthorized sessions, and comprehensive input validation to stop malicious code injection attacks dead in their tracks. Security isn't just a nice add-on, it's literally baked right into the structural steel.
Section 4. Aligning tech with business, project management, and lifecycle.
We've reached the penthouse of our skyscraper. Now we have to tie this brilliant engineering blueprint back to harsh business reality. Deploying a complex digital platform is a constant high-wire act of balancing software velocity against long-term architectural stability. And this brilliantly illustrates 3 critical lifecycle stages. First, product mapping. Operational leaders really have to consider if they need an agile web space or a mobile app first to determine their initial platform rollout. Second, capital efficiency. Startups have to look hard at their launch runways and software expenses to accurately calculate those SaaS build costs. And third, rapid validation. Basically, getting an initial layout to market quickly so you can collect real user data via a minimum viable product, or MVP. Your architecture must support these exact business maneuvers.
So when we bring all of this together, we get the definitive equation for enterprise-ready software. Transitioning an ambitious concept into a scalable, browser-accessible architecture isn't magic, folks. It requires deep system knowledge, clean user experience practices, and robust cloud hosting setups. When full-stack engineers and cloud architects align these 3 elements, they build web architectures that are designed to adapt seamlessly as your company grows.
Which brings us to the final check of our blueprint. Look at the application your organization relies on right now and ask yourself, is your digital product built on a foundation ready to scale, or is it a house of cards just waiting to fall? The modern web is completely unforgiving to technical debt, but it is incredibly rewarding to precision engineering. Thanks so much for joining this explainer. Take these structural concepts, evaluate your platforms, and go build something designed to last.